Hi everyone, we are from Group 12 and our group member has Siti Nur Atikah binti Zainal Abidin and her registration number is 01DKA21F11141. And me, Topi Hua, and my registration number is 01DKA21F1071. And our lecturer is Muhammad Anwar bin Dris. Today, we are going to do a mathematics presentation 2 on the topic of chapter 5, vector and scalar. For my course, DBM 10013, Engineering Mathematics 1. In our video, we are going to present about the introduction, real-life application of vector and scalar, mathematical solution with drawings, conclusion, reference, and credits. Introduction. This topic explains about the basic operation of vector and scalar quantities, including their use in solving problems. It can explain the method for determining angle between two vectors as well as the characteristic of triple vector scalar product. And these are some of the differences scalar quantities and vector quantities. Scalar quantities has only magnitude but no direction. Vector quantities has both magnitude and direction. Every scalar quantity is one-dimensional. Vector quantities can be 1, 2, or 3-dimensional. Any change in scalar quantity is the reflection of change in magnitude. Any change in vector quantity can reflect either change in direction or change in magnitude or change in both. Scalar quantity cannot be resolved as it has exactly same value regardless of direction. Vector quantity can be resolved in any direction using the sine or cosine of adjacent angle. Any mathematical operation carried out among two or more scalar quantities will provide a scalar only. However, if a scalar is operated with a vector, then the result will be a vector. Result of mathematical operation between two or more vectors may give either scalar or vector. For example, dot product of two vectors give only scalar, while cross product of summation of subtraction between two vectors result in a vector.
Let me go to real-life application of vector and scalar. From my research, I have concluded that vectors can be used in many fields such as navigation of aeroplanes, ships, and satellites. They are also used in gene cloning. They are widely used in mechanics, physics, and computer engineering. They are also used in graphics by creating a smaller and edit them to get a real object. For example, firstly, force, torque, velocity. Secondly, crosswind. Thirdly, roller coaster. Let me explain force, torque, velocity. For example, for calculating every vectorial unit, we need a vector. For example, in a moving car, the tire has it also initial and final velocity, acceleration, and gravitational reaction, friction forces, and due to rotation, it has torque. For getting the result, we need a vector. Crosswind. We are familiar with the term crosswind. A crosswind is any wind that has a perpendicular component to the line or direction of travel. When a plane comes to land sometimes it faces difficulties for the crosswind. A pilot can find out the resultant velocity and direction with the help of a vector. The next is roller coaster. Most of the motion in roller coaster ride is a response to the Earth's gravitational pull. When Earth train reaches at a peak point, then rides downhill. It gains enough speed gravitational pull. With this speed, it climbs to the next hill. This process occurs over and over until the train's energy has been lost to the friction. The train will be able to keep running as long as no point on the track was higher than the first peak. Here vectors of forces, acceleration, and velocity are important to make a safety system.
Mathematical solution with drawings. In the diagram below, A and C and B and C are straight lines. Points M and N lie on AC and BC respectively, such that N is the midpoint of AC. 3AO is equal to ON. Given that AC is equal to 3I plus 5J and CB is equal to 2I plus 8J. Replace each of the following vectors in the term of I and J. Find the AC and AO. And to solve this question, first we need to solve the incomplete information. And the incomplete information is 3AO is equal to ON. And to solve this, first we need to over the AO, and it will become 3 over 1 is equal to ON over AO. And after this, we need to change each form. It will become ON ratio AO is equal to 3 ratio 1. And then we need to mark it in a diagram. And we need to continue to find the AC. AC is equal to AB plus BC. And BC is the opposite direction of CB, so it will count as negative CB. AC is also equal to AB plus in the bracket negative CB. AC is equal to in bracket 3I plus 5J plus in bracket negative 2I plus 8J. After that, we need to open the bracket, and it will become AC is equal to 3I plus 5J minus 2I minus 8J. And the last, we get the answer, AC is equal to I minus 3J. After that, we need to find the AO. AO is equal to 1 over 4 in bracket AN. And AN is also equal to AB plus 1 over 2 BC. AO is equal to 1 over 4 and in bracket 3I plus 5J plus 1 over 2 in bracket negative 2I minus 8J. And after we open the bracket, and it will become 1 over 4 in bracket 3I plus 5J minus 1 minus 4J. And after we calculate it, it will become 2I plus J. And the final answer is AO is equal to 0.5I plus 0.25J. In second question, find the angle between A and B if A is equal to 5I plus 8J plus 3K and B is equal to 3I plus 5J minus 4K. And to solve this question, we need to use the formula of this formula can find the angle between two vectors. And to use this formula, first we need to find the A dot B. A dot B is equal to, in bracket, 5I plus 8J plus 3K, and in other bracket, 3I plus 5J minus 4K. And after we multiply, it will become 5 multiplied 3 plus 8 multiplied 5 plus 3 multiply -4. And after that, we will get that a dot b is equal to 43. And then we need to find the a. A is equal to square root 5 square plus 8 square plus 3 square. And we will get it square root 98. And then we need to find the b. B is equal to square root 3 square plus 5 square plus -4 square. And we get it b is equal to square root 50. And after we find out the information, we just replace it in the formula. After we replace it, cos theta is equal to 0.6143, and then we count it, and theta is equal to 52.10.
The last one is conclusion. Vectors have a crucial role in our daily lives as well as in engineering. In engineering mechanics, vectors are used to express quantities that have both a magnitude and a direction. For analysis, many engineering quantities such as forces, displacement, velocity, and accelerations must be represented as vectors. This is all from us. Thank you.